Hello everyone, so in today's video we are going to tackle the second part of partial fractions. Okay, so that is the one which has quadratic factors in its denominator. Okay, so just as we did with the first one, the quadratic factors also has a certain form. Okay, so the form for quadratic factors is somehow like this. So let's say you have an expression over something, right? Now that something is your denominator. Okay, so if that denominator contains a quadratic factor, let's say ax squared plus bx plus c. If this is a quadratic factor, what this means is that this expression cannot be factored into linear factors. Okay, so if this quadratic expression at the denominator side cannot be factored into linear factors, then we can now conclude that it is a quadratic factor. But if it can be factored into linear factors, then we have to do that and then go with the first method I've already showed in my previous video. Okay, so if you have this form of partial fraction, now there's a way to resolve it. Now the way to resolve it is, so if you have this kind of expression, it's equal to, it's in the form ax plus b all over the same quadratic expression. Okay, right, so this expression over here could be anything at all, but mind you, if this expression has a power which is higher or equal to the highest power at the denominator side, then you have to first of all use the long division method to divide it before you resolve it into partial fractions. Okay, now you will not be given, or a question will not be given whereby it only contains a quadratic factor. Okay, yes, a question like that will never be given. It will either be given alongside a linear factor, or it will be given in a form whereby after factorization you will get a linear factor and a quadratic factor, or it will be given in a form whereby the quadratic factor is a repeated factor. Okay, but since we've not yet gotten there, let's stick with the one with linear and quadratic factors. So let's pick a first example. So our first example, let's use this example as our first example. So example 1, let's say we have 8x squared minus 12 all over x, then into brackets x squared plus 2x minus 6. Okay, so we have to resolve this into partial fractions, right? Now the first thing I'm supposed to check is to see whether the highest power at the denominator side is greater than the highest power at the numerator side, or to check whether the expression or the fraction given is a proper fraction. So if you multiply this x, right, this x over here, if you multiply this x with the expression in the brackets, the whole of this brackets, we are going to get the highest power on the denominator side to be 3, right? And since it is greater than the highest power on the numerator side, it means this is a proper fraction. So we can ignore the parts where we are supposed to use the long division method. Okay, so we can then proceed to write our identity. So this whole fraction over here, this whole fraction is supposed to be in a certain form, right? Now, which form is it supposed to be in? We consider the factors at the denominator side. The first factor here is just an x. Okay, now since the highest power of this factor here is 1, we consider it to be a linear factor. And in our previous video, for linear factors, they are always in the form a over that factor, and then that factor in this case is x. So if you consider the first factor, we are going to get a over x. Okay, then plus we consider the next factor, which is a quadratic factor. Okay, so a quadratic factor should be in this form. Okay, quadratic factor should be in that form. So if that is the case, then for the quadratic factor, that is the whole of this, we are going to get something like bx plus c all over, then that quadratic factor follows, x squared plus 2x minus 6. Okay, so this is the form we are looking for, and this is the form of our partial fraction. So just as how we did it in the previous video, we combine the expression at the right hand side to get the same denominator as the expression at the left hand side, so that we just compare their numerators. Okay, so we are going to get, let me minimize it a little bit. Okay, so we are going to get, I think this is too faint. Okay, let's try this and see. We are going to get 8x squared minus 12 all on x in one bracket, x squared plus 2x minus 6. You can just use an equal sign. So we are combining the expression at the left hand side, at the right hand side. So they will have a common denominator, x, then x squared plus 2x minus 6. This is a common denominator, right? Then the numerator will be, so this x right here will cancel out this x, then you multiply it with the remaining expression, right? So we are going to get a multiplying coming, guys. All right, so we are going to get a multiplying x squared plus 2x minus 6, right? Then plus the whole of this also cancels out the whole of that, so we get just x multiplying bx plus c. Okay, so this is where we are right now. Now, since their denominators are the same, we can just go ahead and then compare their numerators. Okay, so we have 8x squared minus 12 being compared with, I always want to use the simultaneous equation method, right? So let's just expand it to get ax squared plus 2ax minus 6a, then plus, we expand the other term as well to get bx squared plus cx. Okay, then we group like terms just like how we've been doing it. So this is an x squared, this is a b squared. Since they are all having a coefficient, since they are all x squared terms, then we can group them in one bracket. Okay, then plus, this is an x term, this is also an x term, so we can also group them. Then plus, we are now left with this last constant term, right? So that should be minus. So minus, or you can just make it plus and then put it in the bracket like this. Okay, so plus negative 6a. Okay, so at this point we just compare the coefficients on both sides, right? So comparing coefficients for x squared, this is the coefficient of x squared at the left hand side should be equal to the coefficients of x squared at the right hand side. So we are going to get this, let's call this equation 1. When we compare the x, there's no x term at the left hand side, right? There's no x term over here, so it means the coefficient of x at the left hand side is 0, but the coefficient of x at the right hand side is 2a plus c. Let's call this equation 2. Then we compare the constants. Okay, so the coefficient of the constant, or the constant term at the left hand side, is negative 12. Should be equal to the constant at the right hand side, which is minus 6a. Okay, so we can just find a from this equation by dividing both sides by minus 6. Minus 6, then here 2 by minus 6. So a is going to be 2. Okay, so you can go ahead and then put the values of a into equation 1 and then into equation 2 to get our values of b and then c. So if we consider equation 1, if we put the value of a into equation 1, this is equation 1, this is equation 1. So if you put a equals 2 into equation 1, we are going to get 8 equals 2 plus b. Then b is going to be 8 minus 2, which is 6. Okay, in the same way, we put a equals 2 into equation 2. Okay, this is our equation 2. So we are going to get 0 equals 2 multiplying 2 plus c. Okay, so that means 0 will be equal to 4 plus c. C is going to be minus 4. Okay, so we've been able to find the values of a, b, and then c. So we have a equals 2, b equals 6, and c equals negative 4. So at this point, what we are going to do is just a substitution into the form of our partial fraction, okay, which is this expression right here. Okay, so that means for our final answer, therefore 8x squared minus 12 all over x out x squared plus 2x minus 6 will be equal to, the first term was what, a over x, and a was 2. So we are going to have 2 over x plus, the next is bx plus c. What was b? B was 6, right? And c was negative 4. So we are going to get 6x minus 4, and the whole of this over x squared plus 2x minus 6. Okay, so this will be our final answer for the fraction. Alright, so let's move on to a different example which also contains a quadratic factor as well. So let's try this example. So this is example 2. So let's try x power 5 minus 2x power 4 plus x cubed plus x plus 5, and the whole of this is being divided by x cubed minus 2x squared plus x, then minus 2. Okay, so you can decide to pause the video right here and give this a try. Okay, so to solve this, we first of all have to check whether it is a proper or an improper fraction. So is this a proper or improper fraction? How do we know? The highest power of the denominator is lesser than the highest power of the numerator, so this makes it an improper fraction. So the first thing we are supposed to do is to use the long division method to divide this fraction. Okay, so let's do that very quickly. So x cubed minus 2x squared plus x minus 2 comes out, and then x power 5 minus 2x power 4 plus x cubed plus x minus, okay, it's plus 5. Alright, so we now have this, just as we always do. Take the first or the highest order of x, then you take the highest order of x to inside. So it's the inside one being divided by the outside one. So x power 5 divided by x cubed gives us an x squared. So we multiply this x squared with the whole of that. Okay, so x squared times x cubed gives us an x power 5. X squared times minus 2x squared gives us minus 2x power 4. X squared times x gives us plus x cubed. X squared times minus 2x. Alright, I think I made a small mistake over here. Okay, so we can see that after the x cubed term over here, right, there should be an x squared term, but that x squared term was omitted. So if it gets omitted, you just improvise and then introduce your own x squared term by making it a plus 0x squared. So we just introduce our own x squared term. So yep, like this, then plus x plus 5. So it follows like that. Alright, so that's how it's supposed to be. Now back to our division, our multiplication as we were. So this x squared multiplies this x to give us an x cubed. Yep. Then x squared multiplied by minus 2 gives us minus 2x squared. Okay, so this is what we are having right now. So we do a subtraction. 0 minus negative 2 gives us a positive 2, so we get plus 2x squared. Okay, x cubed minus x cubed gives us 0. Minus 2x power 4 minus negative 2x power 4 also gives us 0. Then this and that also gives us 0, right? So we are just left with this. Then we can proceed and then add our remaining terms. So plus x plus 5. So this is what we are having. Now we are going to end here because the highest power of our divisor here is 3, but the highest power of our remainder here is 2. Okay, so that means we can no more divide it again. So we are going to leave it here. So this is what we are now having. Okay, so our original fraction in the question, which was x power 5 minus 2x power 4 plus x cubed plus x plus 5 all on x cubed minus 2x squared plus x minus 2. This becomes quotient. The quotient is what we had over here. Quotient is what we had over here. So that is x squared. So it's a quotient plus your remainder. The remainder is what we have right here. Okay, so what's our remainder? That is 2x squared plus x plus 5. So quotient plus remainder, and then the remainder is being divided by the divisor. Okay, so what's our divisor? Our divisor is right here. Okay, so our divisor is x cubed minus 2x squared plus x minus 2. Okay, so this is what we are now having. Now you can see that after getting to this point, if you check this fraction, okay, we can now see that this fraction is a proper fraction. Okay, so we've been able to reduce the original fraction, that is this one, by using the long division method to a proper fraction. Okay, so we can now proceed and then use our methods to derive our final answer. Okay, so we are now focusing on this fraction but not this quotient, right? Because this is not a fraction, we cannot resolve it. So let's now focus on the new fraction we have, plus 5 on x cubed minus 2x squared plus x minus 2. So we are now assuming that this is what we are having, this is what we are supposed to resolve. We are now assuming that this was the original question. Okay, so what do you have to do if you want to resolve a fraction? You check to see whether you can factorize the denominator. Okay, so can we factorize the denominator? Let's confirm. I'm just confirming with my calculator to see. So yes, you can factorize it. Okay, so you can factorize out x minus 2 from the denominator. Okay, now since this video is not really about factorization, I'll just proceed and then let's just go through it. All right, so you can do it somewhere else. It's not really part of the solution to show how you factored out the common expression or something. Okay, so I'll just quickly do it right here using the factorization method. So we can factorize x minus 2, right? Okay, I think this is pretty simple over here. You can just group them like this, one bracket, then plus and x minus 2 also in one bracket. So we can factorize x squared here, and then also like this to get x squared plus 1 x minus 2 in one bracket. Okay, so this is what we get when we factorize. So we can write this fraction as 2x squared plus x plus 5 all on x minus 2 and x squared plus 1 in one bracket. Okay, so this is what we are now having. Okay, so we want to write the form for the partial fraction. Okay, so the form for the partial fraction, so this is supposed to be in a certain form. Okay, so we check the first factor. The first factor is a linear factor, so it's supposed to be in the form a over x minus 2 plus the next is a quadratic factor. Okay, we can no more factorize this. Okay, we can't factorize x squared plus 1, not in the real number system. Okay, in a complex world we can factorize it, but in the real number system we can't. So this is a quadratic factor, so that's going to be bx plus c all over x squared plus 1, right? So we are maintaining the same thing. Please don't use this in an official work. Okay, I just want to illustrate that we are still maintaining what is already here. So this will be equal to, so we get a x squared plus 1, then bx plus c x minus 2. Okay, all of this on x minus 2 x squared plus 1, right? So our denominators are now equal. Let's just compare the numerators. So we have 2x squared plus x plus 5 being compared with, let's expand it to get ax squared plus a plus bx squared minus 2bx plus cx minus 2c. Okay, when you get to this side, it's just a matter of expansion. Okay, just expand the brackets. Okay, so we group like terms. There's an x squared, another x squared, so we put them in one bracket. This is an x, this is an x, also put them in one bracket. So minus 2b plus c, and then this is a constant, this is also a constant, so we put them in one bracket as well. So this is what we are now having, right? So from here, what we are going to do next is to compare the coefficients and resolve them simultaneously. Okay, so comparing the x squared, we are going to get 2 equals a plus b call this equation 1. Comparing the x's, the coefficient of x here is 1, right? That will be 1 equals minus 2b plus c. Then the other one is a constant. 5 will be equal to a minus 2c. This is our equation 3. So if you proceed and then you solve these 3 equations simultaneously, you arrive at a being 3, then b is -1, and then c will be -1 as well. Okay, so by solving the 3 equations simultaneously, we are going to get a equals 3, b equals -1, and c also being equal to -1. Okay, so these are our values of a, b, and c. Just substitute them to get your final answers. Okay, so we are going to get x power 5 minus 2x power 4 plus x cubed plus x plus 5 all over x cubed minus 2x squared plus x minus 2 being equal to x squared plus, so we are now looking at the partial fractions we wrote, right? We had a over x minus 2 and a is 3, right? So this is going to give us 3 over x minus 2, then plus bx plus c over this whole thing, right? This whole thing. So that would be plus, what was our value of b? B was -1, right? So if we replace -1 here, we're going to get minus x, and then c was also -1, so this is going to give us -1. So we can just bring out minus out, then write it as this. So we can now write it as that. Okay, so we can just ignore, because there's a minus and then a plus here, we can just ignore this one and write it as negative. Okay, so that will be minus x plus 1, and the whole of this dividing the quadratic factor. Okay, so this will be our final answer. If you have any questions to ask about this, feel free to drop it in the comment section. Please do also like, share the video, comment, and then subscribe for more videos.